Welcome. Thank you, Product Board. Thank you, Martin, for the previous presentation. I hope there's some degree of overlap, but not too much. My name is Vojtěch. I'll be talking about a project that I've been involved in now for a few months. And I'll be talking about AI augmentation for call centers. Essentially, what we're trying to do is we're trying to help some of the people working in the call centers of our client and give them some more functions, some more tools to do their job better. We've all been to meetups before. We know how this goes. Before getting into the topic, something about Accenture, the company that I'm working for, and the ones on behalf of which I'm here. It's a consulting company implementing technologies, trying to leverage all kinds of technologies to build solutions to serve the customers. We have lots of credentials. With big company comes big credentials. So we have Everest Group, Gartner, Forrester, HFS, IDC. If that tells you something, then great. And if not, then moving on. In Prague, we have a applied intelligence practice. What does that mean? We use artificial intelligence, data science practices to deploy solutions with our customers. Now, of course, just building a solution, it's not that easy, especially in large organizations. So based on the maturity of our customers, we might do data strategy, implementation, governance, or how do I get the most value out of my solutions. Cool. Now that that's out of the way, let's move on to the interesting part, some agenda. I'll be talking about the business context of the solution. Then I'll go on to the platform that we used for this solution. Then I'll go into solution design. I'll dive deeper into 3 AI topics, and then I'll give you my personal learnings and takeaways that I think are applicable to most projects. So let's start with the business context. We have a client. I will not name this client because that's under NDA. But our client has a call center. It's a large client that needs a call center to address issues, to answer questions regarding our client's products and services. Our client is present all around the world, in all the European countries, which is our focus. And we want to speak natively with all of the callers from all of the countries where our client is active. So you can imagine some 27 or so countries, and that means some 27 something languages. We need live agents that speak those languages, and we have one call center, which means that we need the people that speak all different languages in this one specific location. And that's a problem. It's difficult to get Norwegians and Bulgarians and Slovenians and all these different nationalities in one call center to answer questions, especially if we want 24/7 support. We need three shifts, so 3 times, let's say 27. You can do the math, around 80 people. This is not really financially feasible, which leads to understaffing, which leads to poor customer service. We're trying to fix this current situation by, to these live agents, we want to give them that robot which can speak different languages and can retrieve information and hand it over to the agents, so that they don't have to spend time, typing out or typing out answers, or thinking, where do I find the right information? All they have to do is sort of kind of curate the conversation and pass on this information. This also means that we don't need all of these languages. If we set it up right, we just need English-speaking agents that can address all of these different languages. Now, if we have 3 callers from Norway per day, one agent can serve multiple countries. They don't have to focus on Norway. They can focus on Norway, Slovenia, France, and so on. That's the business context. I mentioned that we used a platform to build this solution, and I know that platform-driven development is unpopular. How do I know this? I checked Reddit and I have spoken to developers, and everything tells me that low-code software development is a lie. I'll try to make the case that it's not a lie and that it is useful in some scenarios. For us, it's helped us a lot. Actually build the solution, build some sort of MVP, some functioning product, and we'll be testing it next week in person. There was before choosing the right platform, we had some sort of framework to select it based on what we need. So we have, for example, our Accenture tools, some sort of templates, some sort of code bases where we can build, for example, intent discovery, conversational AI automation, all these different features ourselves by using those kind of template solutions. But then there's a lot of custom building. We would have to do a lot of things ourselves. For example, conversation orchestration. Conversation is a dialogue, and there's a lot of back and forth. And orchestrating this would mean that we can't spend time on the interesting AI tasks, and we would be focusing on on the logic behind the conversation. That's the Accenture tools. We can also use very specific products from, for example, local startups, local product companies. Here on the screen, I put Czech companies, Born Digital, WeBoard, and Prometheus, to give them some sort of PR to support the local market. Now they of course offer really cool products, but in this use case, they didn't address all the issues that we needed. For example, we needed this live agent functionality. We wanted to use a knowledge base to be able to retrieve information. And that's why we went with this specific platform, which I will tell you a little bit more about. So it's a low-code conversational AI platform. You probably are familiar with the Gartner rankings and so on. It's one of the leaders there. What does the platform actually look like? So it has a bunch of different modules, and it integrates with many different extensions very easily through API calls or through the extensions where you don't have to deal with the API calls. You just authenticate it connected, and it works on its own, so to speak. So Cognigy, it has, for example, Cognigy flows. That's the main thing. Flows are a visual representation, diagrams of the logic that happens in the conversation. So maybe a customer calls, you first want to say, hi, thanks for calling, we're going to be assisting you with this and that. An agent will be connected soon, and then some sort of back and forth. This is where we do the orchestration. Cognigy also has, for example, NLU, natural language understanding. This is essentially, what is the caller? What is he interested in? A bunch of other components. For example, LLM orchestration. It also connects with Messenger, WhatsApp, Teams, Slack, IoT devices. Now we didn't use all of this. We don't need to control homes. We just want to build a call center. So we used Genesis, which is customer service as call center as a service. We route this to our Cognigy. Here we have our logic, and then we integrate with Azure Speech to Text, OpenAI's GPT models for vector database vectorization and for summarization, and then this live agent desktop. We don't use these other ones. Okay. On to the most interesting part. This is the solution. This is the solution. This is the conversation. I'm being reminded to protect my stuff. I don't know. I'll try to keep going without addressing that. Hopefully, it doesn't mess up the presentation. So, let's walk through the conversation itself. So we start here on top, where we have our customer calling in to ask a question. And he may be interested about, how do I activate this product on my phone or elsewhere. So the first step is that we use that Genesis call center as a service. We process the audio coming in, and we have an audio recording, which we can pass to our speech-to-text model. Our speech-to-text model is in Azure. There we transcribe it to text, so from audio to text. Text string of words or that piece of text, we translate it to English. This also happens in Azure. At this point, we log the sentiment of the customer. We want to know, is he positive? Is he really angry? And then we also display this for the agent himself or herself, so that they have some sort of idea how the conversation has been going. Next, we in Cognigy, we detect the intents and the entities. I'll talk about this in a little bit more detail in a second. Essentially, we're trying to understand what is our caller interested in it. Here, it goes behind my notice, my final notice. We fetch the relevant information based on using the GPT model. So we go into our vector database, and we get the right chunks. Then we summarize the chunks or the information that we got. And finally, we get to our second human in the conversation. So we have the customer on top. Then we have a sequence of automated events or modules. And we have our human here. Our human here gets the question that the customer asked. So this is this translated and transcribed part. The agent sees it. And in the meantime, this happens within maybe half a second, maybe 1 second. And he gets the answer pre-prepared. And what he can do, he can accept that answer. He can say, okay, it's not perfect. It doesn't sound like a human. So he can edit it. He can maybe fix some typos. He can fix some of the information to make it correct. And then, or he can write his own. He can completely ignore the recommended answer. Once the live agent sends this, he sends it off, and it is first translated to the original language, so the native language, and then it is synthesized, and then we have a recording which we sent back to the customer. So what I'll be now diving into is the 3 machine learning topics. This is a ML meetup. So I'll be talking about the speech to text, a little bit more detail about this. Then the intent and entity recognition and search, and then our GPT part. I'm now realizing this is going to be an issue, but hopefully the voiceover does it. I don't think I can click on. Oh, yeah, maybe I can. I've pressed this button like 10 times now. There we go. Okay. Cool. So first, the first topic, which is the speech to text. Now, on the previous slide, you maybe saw this. I referred to this as the single point of failure. If we don't get a good speech to text transcription, the whole solution breaks down, and basically it's just a loop of the agent saying, "What do you mean? What are you telling me?" And the customer getting more and more frustrated trying to repeat his question or request. So we need to make this really, really good. Unfortunately, if you've ever worked with speech-to-text models, they're not perfect. If you've used Siri or Alexa or something, you know, it doesn't always work. So the out-of-box solution doesn't cut it, and we need to customize it. We customize it by uptraining the speech-to-text models. And what we focus on is foreign words. So by foreign words, I mean the products or the services and their names of our client for whom we're building the solution for. Alternatively, also just English words. For example, AI. If I say AI to a Czech model, it might transcribe AI, but I actually want the first one. So we need to teach it, and we teach it by using various different various formats. We can speak at it and give it the transcription. We can use these types of pronunciation files where we first give it the word, and then we give it the phonetics of that word, and hopefully it recognizes and it learns. So here our goal was near perfect transcription. As I said, this is a single point of failure. If this fails, the whole solution fails. But we're not going to get it perfect, especially for some of the smaller languages where we are very limited with training formats. So we created some sort of subjective scale. So we have perfect, that's number 1. We have 4, which is incomprehensible, completely useless. I don't know what you're saying. And then something in between, which is either minor errors or major errors. Now, of course, this is very subjective, but it works, at least for us so far. And how does that work? It works the standard way. We first identify the problematic words, which will be those product and service names of our customer. Then we move on to creating a training set and a testing set. So we will use those different formats, maybe speak at the model and give it that transcription, maybe those pronunciations, maybe just example sentences or names of products and services. And we create this. Now, when we're working with Estonian and so on, I don't speak Estonian, so then we have to get an Estonian person and do a back and forth of basically this loop. Then we uptrain the model. Then we do this testing. We identify the problematic words. We move on to training and testing sets. And then we repeat this 2 or 3 times, at the end of which it's typically good enough. So here are some of the results. I didn't put the language names to keep it really safe with that NDA. So we have 4 languages here, which are the languages in our MVP. We started off on that subjective scoring of from 2 to 2.5. So that's somewhere between easily understandable with minor errors and somewhat understandable with major errors, whereby the errors are typically those product and service names, which is pretty important for our solution. Over time, we go through those iterations of training and testing and identifying problematic sentences, and we trim down those error rates. Well, very subjective scoring. It performs better and better. It doesn't always perform better. I can reveal this is the Czech model, and it goes a little bit. It improves, then it worsens, and then it improves again, and then we say, okay, that's enough. Here, the main limitation is lack of training options for minority languages. So 2 weeks ago, last week, I was on a call with a Bulgarian colleague, and all we had there available is plain text. So we had to get very creative, and also Bulgarian does not use this alphabet, but I don't remember the name, but the Russian-style alphabet, which makes it very difficult for actually verifying the results for someone like me or my colleagues. The point here is that out-of-box doesn't work. The technology is really, really cool, and it's pretty fun to uptrain these models, but you need to put in the work. Next topic, so that's topic number 2, is avoiding exponential costs with frequently asked questions and their handling. So of course we can route all of the questions from our callers to GPT, but if we apply the 80-20 rule, we'll get 80% of the customers asking 20% of the questions, which is a pretty robust rule, where we can just take those top 20% of all questions answered from the call center's past questions asked from that database, and we can just pre-prepare those answers. And suggest them to the live agent right away, completely avoiding the GPT part. So that's what I'm talking about. Here I have 2 options for retrieving information. The first option is this predefined answer matrix, and this is where intents and entities start playing a role. So when I say intent, I mean, what does the caller intend on learning about? So it might be, what is this product? Is this product available for me? How do I make this product, or how do I make this service work? And is it available in my country? And then a few more. And then entities are those products and services. So we can imagine if our caller asks, for example, how do I make product 1 work, which is service enablement? How do we make product 1 work with service 2? So all we have to do is take these specific answers, bunch them together, maybe summarize them, send them to the caller. Well, send them to the agent. Agent can send them to the caller. Option number 2, if this fails, so here I have some sort of logic. So if we recognize the intent and if we recognize the entity, great, we have the answers ready. What we can then do is summarize them, maybe humanize them a little bit using a GPT prompt, send them to the agent. If this fails, then we have our vector database where we have our documents uploaded. If we upload documents to a vector database and we use, for example, OpenAI's embeddings model, then it'll get stored in a certain way into little chunks. So these might be paragraphs, these might be sections from subheading to subheading or from heading to subheading. There's always some sort of logic. And then when we don't recognize these intents and entities, we forward that question to the embeddings model, which then fetches the most relevant chunks. We take the top 6 chunks because that has given us the best results. Then we summarize those 6 chunks and pass it on to the agent. And the story, the point of this story is that it's not just about making it work. We want to make it affordable. So far, it is affordable, and so we're actually doing both option 1 and option 2, also to see what the results are like. But if we get to a point where we have multiple callers per language and multiple languages, and then we spread this over a month, there's a lot of cost that we can avoid by implementing this simple logic, and that definitely makes our client happy, which is the ultimate goal. Third topic. Now this is where there will be some overlap with Martin's presentation, although I won't be going into that much detail, as you already know. The idea here is that we all need context, and we all need instructions, and we all need restrictions. Otherwise, we're going to make stuff up, and we're not going to be good on the job. So when we do the summarization and we want to pre-prepare this answer for our live agent, then we have this prompt where we have those documents we retrieved from the previous slide here. And now we really want to package it in a way that the live agent has to just press enter or command enter, and it can get sent off. So what we give to our model. First, we say you are a virtual assistant for company X. Company X being our client. Your task is to answer questions based on the information returned from the knowledge search. We give the knowledge search in a second. We give it some instructions here. I've cut this off a lot. Cut most of the task instructions because there's multiple different examples. But one of them is, for example, if a question pertains to a specific country, or if a question pertains to a service in a specific country, identify the country, identify the continent, verify if the country is mentioned in the documents, and if it's not, then provide an basically say, okay, it's not part of the scope, it's not listed as supported. If you do, then find that section, right? Find those chunks and use that information. Then we provide it with the top documents. This could be predefined answers. This could be those vector semantic search results. We provided the question, and then very important point, we provide the conversation transcript. So if I ask you, how do I make product 1 work? You tell me the answer, and then I say, okay, how much does it cost? Then the GPT model is going to say, how much does what cost? We want to avoid this, so we always pass in the conversation transcript. This is also important to keep in mind when we do the cost calculation of these types of solutions. So moving on, we give it the instructions on how to give us the output. So we say be concise and be truthful. Now, if the answer is not provided in the documents, you may use your training data, but that condition is important. And it has to match the context based on the conversation transcript. And then final part is format and style. So please answer in English. and use simple plain text with no extra metadata, and then we get to those restrictions. So we give it some sort of do not list, do not offer to contact customer support, do not tell them to check the information themselves, because that's your job. Do not talk about prices, and definitely do not talk about competitors. A customer would not be happy. Finally, you're emulating a human, so keep your language friendly and easy to understand. This also does not always work. So that was the third topic. Important message on this topic. Martin already highlighted. As a technology, it's cool, but it does not work on its own, and it's far from perfect. Okay, so finally, some learnings and takeaways. The main learning here is early testing is invaluable because of the solution that we're building. So I draw the learnings and the takeaways, again, personally, on 3 different levels. The first level is the technology itself. Yeah, I've mentioned this a few times now. Even if it's impressive, like ChatGPT is impressive, we can't expect it to expect out-of-box perfection. And this was very true with the speech-to-text models, which, if that's not perfect, and we really want perfection, then the whole solution fails, and we're just making our customers more angry than before. The takeaway is that AI is just a starting point. Pushing from 80% to perfection is the main challenge, right? Anyone can bunch together a few prompts, but that perfection is hard to attain. Level 2 is the platforms. So when developing a cohesive solution, modularity and flexibility is the most important part. The reason why Cognigy has been a relatively good experience is because we don't have to spend time on orchestrating the conversation. We don't have to deal with, for example, what Martin was talking about, the timeouts of OpenAI and their APIs, rate limits, all that stuff is handled by Cognigy, and we can actually focus on the content of our solution. So I recommend, if you do choose to work with platforms, then choose platforms that have elaborate integration and extension options. I hope Product Board has that. And then the last one is on the project level, and that is my main point. Early testing is invaluable. If we're dealing with new technologies like ChatGPT, and if we're building solutions on these technologies, we don't know how it's going to go, right? If we're building a data warehouse, we can tell what the difficulties will be. But with these technologies, it's not always as expected. So aim for short development times and communicate with your client frequently. That's it. Thank you for your attention. I'll be answering questions now. And of course, as the policy goes, check out Accenture Careers. Everyone's always hiring. And if you want to grab a coffee, talk about this stuff, talk about something else, talk about music, then this is my LinkedIn, and or just come up to me after this. So that's it. Thank you. Okay, so how do I do this? No. There we go. All right, so question time. I've just been taught how to use this thing. So let's highlight it. How do you process customers' data in a private way? For example, if they share names, address, or even credit card number, what techniques do you apply apart from standard security measures? For example, filtering of personally identifiable information. So this call center is really for a specific type of digital product and service. So when we give information, I assume you're asking about the GPT prompts. Maybe specify the one who asked the question? Is that the case, or is it just in general? Maybe it was someone from the stream. Okay. Then if it is for GPT, then we don't actually pass on information to the model that is sensitive. We only pass on the questions. Currently there's no handling of, for example, bank details, but we'll never ask bank details. That's also mentioned in the prompt for the recommended answers. What we're using GPTs for is indeed those recommended answers, where we have that database, and we're putting, in general. Wow, perfect. In general, so we have it in a database, and how it works is that if your phone number is recognized, then we can pull up the phone number and pair it up with your personal information, and then the only things that we display is the country that you're calling from, which is obvious. Then maybe your name and maybe the products or services that you have enabled. Again, I'm trying to dodge the NDA traps here, the information, of course, is available to the live agents, but those ones have access to, have permission to view the information. And if you're calling, then we're talking about your products and your services, so we can speak with you about it. So I hope that answers the question. Isn't there a problem with delay of the response to the calling customer if the live agent has to edit the response? Yes, very good question. And if I showed you the demo, this is exactly what we would be talking about here for maybe 20 minutes. Especially from the beginning, we had big issues because indeed you would call. Now it happens, right? It gets to the live agent. The live agent has to read it. Within a second, he gets the recommended response. He has to read that thing as well. Then he has to evaluate, is this good enough? Do I have to edit it? If he doesn't have to edit it, okay, you send it off. However, if he does have to edit it, he has to type, and that can take 5 seconds. And the customer will just be there. Am I still talking to someone? Have you left the conversation? So what we introduced, although this is still a working feature, we introduced basically a recording, multiple different phrases that we cycle through, or we play randomly, which is, hey, I'm still here, I'm just looking through the documentation. Please be patient. Thank you. Thank you for your patience. These types of things, and it actually did a lot. We repeat it every 5 seconds or so. Then it gets annoying if the caller is waiting for like 20 seconds and he's maybe heard the whole thing, all 4 of them. So yeah, it's still work in progress. It also translates funny to different languages. But yeah, that's why we're going to be doing testing. I hope that answers the question. Moving on to the next one. Very good question, that previous one. Is there a pure whisper model behind the Azure ASR API? How do you enforce foreign words to it, since it doesn't have separate language model which you can fine-tune on domain data? If it's whisper, do you fine-tune it for each customer? Again, some speech-to-text specialist in the room. We are not using the whisper model. That's OpenAI's model. At the moment, at least in West Europe, in that region, it's only available for batch data. So for us, it's not possible. It's not relevant. We need real-time data or real-time processing. But I've heard that it works well. I'm not sure how it works with uptraining though, because that's the most important part. And so those foreign words, we use it for that standard speech-to-text model. And yeah, we don't use the whisper model, and that's all. What speech-to-text model did you use? We used Azure's speech services, and then there's basically 1 or 2 pre-trained baseline models, which were trained typically 2022 or 2023. For every language it's different. For every language the maturity is also different. So we use the latest non-whisper speech-to-text model from Azure. Why did you use the subjective score instead of the standard word error rate metric? Is there any mapping between them? Also, a good question. I'm not sure. I think it's because when we started the testing, we were... Yeah, actually, I'm not sure. I was not part of that decision. That decision was made before I joined the team. But I guess it's because we were doing early testing. So we basically, to test, since the beginning, we would actually have people calling in, and we would be evaluating the transcription. But it's definitely something to consider. There is an issue with this. So if in Azure, when you're training speech-to-text models, you do have this. You can do like this. There's this testing section of it, where it does give you the word error rates and then like 5 other variations of these quantitative measures. The product names and the service names, the way those are made up is very similar, for example, to product board. So we have product board. Now, if you tell it product board to the check model, speech-to-text model, I'll say product board, and I want it to recognize that single word of product board, and it identifies product and board. So it actually tells me that it's a 100% error rate because it did not identify what I wanted it to. So that's one slight limitation of these approaches to evaluation, and we do see that a lot. So I'll get a 66% error rate on my testing set in Azure, but I know that it's actually a lot better because of these issues. What vector database do you use? We first use Cognigy's knowledge store, which is the platform that we used. They have their own vector database, which makes it very easy to do manage documentation. We have now moved away from it to the customer's vector database, as they have different, though they have a vector database and then they have it for specific teams within the whole organization, and they want to have it centralized. No specific name dropping. Do you detect the sentiment based only on the text? What if the client should shout the normal words, which have a neutral sentiment label? Again, great question. At the moment, it's only on the text, and yeah, if you scream, it's not really gonna change because it's only taking the words. Eventually, you're gonna start using foul language probably, so we'll detect that it's negative. But at first, indeed, that's not the best approach. That's the feature to be added in V2, V3 when that's available. Unfortunately, we don't have this available in Azure, so we would have to use some other provider or developer's personal code, which would be a lot better. But at the moment, it's out of scope. How did you extract the most often asked questions? So we basically, this call center has been around for a while, and they just went through all of the questions. Well, not all of the questions. They went through. They spoke first to the people that work in the call centers, and then they provided some, and then they went again through the past questions asked. So it was, again, I was not part of that because that was the very first part of the project. Very manual exercise, I can imagine. Probably not very fun to do. Stepan, in your opinion, how close are we to something like real-time any language translator, like from Star Trek? I have not seen Star Trek, so I apologize to the person that asked the question, and probably half of this audience that hates me now. How close are we? I would say we're not that close, especially when using those. For minor languages, we're not close. for major languages, I would say we're close. I remember seeing this video, and I don't remember the company that did this or the open source community behind it, of somebody speaking in English, recording a video, running it through this one thing, although it was not real time, it was batch. And then the whole video, including the articulation, the way the mouth moves, in French, in perfect fluent French, with all the funny, like the intonations of the French. That was really impressive. And I think for those large languages, there's enough data. But for the Bulgarians and the Norwegians, the really small languages, I think we're pretty far. Well, what is far these days, right? But we're not there yet, that's for sure. Well, do we still have time for questions, or one more? What is the time between when the customer asks a question and when the operator sees the suggested answer? The time is, I think it partially depends on, are we using the vector database, and are we doing semantic search? That takes a little bit longer than the predefined answers. I will answer in the range of 1 second to 2.5 seconds. Yeah. Good thing is that the agent first sees the question. That's immediate. As soon as we transcribe it, as he's reading it, it's called agent assist. The recommended answer shows up on the screen. So hopefully that delay is not an issue. That's it. So if I can answer some of these questions after, then just catch me here or text me, and I'll be happy to answer them. Thank you.